we're going to do a little diagram of heart failure and how it all affects all of the body. So first you have, we'll say the first, okay, so you have your right side of the heart, which then go to your lungs, right? And then you have the left side of the heart, which then will go down to your kidneys. Let's do your kidneys here. So that goes down to here. At your kidneys is where you have your, remember you have your glomeruli and your renal tubules, stuff like that, okay? And then it's gonna circle back to the right side of the heart, okay? So with heart failure, you have one of two issues generally. So your first issue is going to be you have atherosclerosis. Okay? So when you have atherosclerosis, this causes an increase in systemic vascular resistance, right? Okay, so say you have your blood here, okay. So if you have really hardening and buildup of atherosclerosis, okay, then it's going to increase the systemic vascular resistance. It's going to increase the pressure that the left ventricle has to move against in order to get blood out to circulation, right? So what happens is it causes this muscle to get this left ventricle to get really fat, okay? Because it's having to work harder and harder and harder and harder, right? So we have hypertrophy. So we have left-sided hypertrophy. And unlike other muscles in the body, when this muscle, of course, is working harder and harder, so it's getting really bulky, just like other muscles, right, in the body. But the problem with this is when the heart gets really big and bulky, it becomes less effective. And it means that it can't squirt out blood very effectively, okay? So what happens is blood will end up hanging out, going backwards, okay? So it tends to, here, let's make this a different color. Okay, so our blood will go back, okay? It doesn't all go out into the body. It's going to hang out in the lungs. It's fluid back up in the lungs, and you get pulmonary edema, okay? So you get juicy lungs. You get edematous lungs. So you get pulmonary edema. Because it's so much pressure to try and squirt out that left side that blood just backs up into the lungs. Okay? So that's one of the major causes. Another cause could be that these renal tubules get clogged up with stuff. It can get clogged up with, so your other cause. We'll circle these. So, blocked renal tubules. Well, if you're blocking your renal tubules, make this red again because it's what the blood's doing. So if you're blocking the renal tubules, the blood can't get to where it needs to go. So it backs up. And it causes an increase, okay, so you have an increase in your intravascular fluid volume. Okay, which causes also an increase in systemic vascular resistance. So then you have fluid that's weeping out of the vessels. It weeps. Okay, and that weeping out of the vessels is what causes the edema. So basically, let's go back to black. What happens is all of this it causes, left side of the heart hypertrophies from working so hard. Okay, and I don't know why I did that. And so it becomes all bulky eventually. And an ineffective muscle. And then you have, the blood is not pumped effectively, and you have poor perfusion, and you end up being tired. So the initial therapy is helping with this one. So our initial therapy, we're trying to help the hypertrophy not happen, okay? So we're trying to keep the heart from working so hard. So we're trying to decrease the work of the heart. And we do that with drugs that will decrease the volume of the blood, decrease the heart rate, or that decrease the contractility of the heart, the contraction. Okay? But once the hypertrophy has happened, the heart becomes bulky and ineffective, we go to later therapy. And we have to try and make, our goal here is to make the heart more effective. Okay, so how we do that is with positive inotropes, which help to make the contractions harder, and with increasing our heart rate, trying to get circulation better out there. Okay, so these are the medications that we're going to be talking about. Medications that either are used in initial therapy that help to decrease the work of the heart, or that are used in later therapy after the heart's already gotten hypertrophic and it's ineffective, and so trying to get the heart to be more effective than it is. Okay?